You feel 2 pinpricks on your ankle. Sharp, almost nothing. You look down and see a shape sliding back into the grass. If this happened to you today, you'd be in an ambulance within minutes, hooked up to a vial of antivenom within the hour. 99 times out of 100, you'd walk out of the hospital in a day or two with a good story. Now go back 50,000 years. Same bite, same venom, same 2 pinpricks. Except there's no ambulance, no hospital, no vial of anything. There's just you, whatever your body can do on its own, and whoever happens to be standing nearby. For most of human history, a snake bite wasn't an inconvenience. It was one of the most dangerous things that could happen to you, and there was almost nothing anyone could do about it. So let's actually walk through it. What happens to your body in the minutes and hours after the bite? What your fellow humans tried to do about it, and how long it took our species to come up with something that actually worked. The bite itself. Not all snake venom does the same thing to you, and that split matters more than almost anything else in this story. Some venom is neurotoxic. This is the venom of cobras, mambas, kraits, coral snakes. It works on your nervous system directly, blocking the signals that travel from your brain to your muscles. Early on, you might notice blurred vision, tingling, trouble speaking. Left alone, that creeping paralysis eventually reaches the muscles that control your breathing. With the fastest, most potent neurotoxic bites, death from respiratory failure can happen in under an hour. Other venom is hemotoxic. This is the venom of most vipers and pit vipers. Instead of shutting down your nerves, it goes after your blood and your tissue. It stops your blood from clotting properly, so you start bleeding internally, sometimes from your gums, your nose, anywhere. It breaks down blood vessels and destroys the tissue around the bite, which is why untreated viper bites so often end in amputation, not just death. This kind of venom usually takes longer to kill you. Without treatment, most people die somewhere between 12 hours and 3 days, as organ after organ starts to fail. And some venom is cytotoxic, which mostly just destroys flesh where it lands. Painful, disfiguring, and if it goes untreated long enough, gangrenous. Here's the part that should stop you for a second. This isn't ancient history. Right now, an estimated 5.4 million people are bitten by snakes every single year. Up to 140,000 of them die. 3 times that many are left with permanent disability, amputated limbs, ruined tissue, nerve damage that never fully heals. And that's with modern hospitals existing somewhere in the world. For the vast majority of human history, none of that existed at all. And here's something that makes it worse. Some animals evolved actual biological armor against this. Mongooses, honey badgers, hedgehogs, they all independently develop mutations in the very receptors that neurotoxins latch onto, so the venom simply can't bind the way it's supposed to. A honey badger can take a bite that would kill you and barely slow down. Humans never evolved anything like that. Whatever dose kills a rat kills you too. Every single advantage we ever gained against snakebite, we had to build ourselves from scratch, with nothing handed to us by evolution. Why your body already knew to be afraid. Before we get to what people did about snake bites, there's something worth understanding first. Your fear of snakes isn't something you learned. It might be older than humans themselves. There's a theory in evolutionary biology called the snake detection theory, developed by anthropologist Len Isbell. The idea is that snakes were one of the very first serious predators of early primates tens of millions of years before humans existed, and that this predator-prey relationship is part of why primates evolved such unusually sharp vision in the first place. Researchers have even found neurons deep in the primate brain, in a region called the pulvinar, that fire faster and stronger at the sight of a snake shape than at almost anything else, including other primate faces. Some studies suggest humans can detect a snake in an image before we're even consciously aware we've seen it. In other words, by the time actual humans showed up, we were already walking around with millions of years of built-in snake paranoia wired into our brains. That fear wasn't irrational. It was earned one bitten ancestor at a time. What people actually tried. So here's a species with a deep, ancient fear of snakes, no understanding of venom, no germ theory, and no medicine as we'd recognize it. What do you do when someone actually gets bitten? The honest answer is, whatever you could think of, and mostly it didn't work. But the most detailed ancient manual on the subject is Egyptian, called the Brooklyn Papyrus, dated to somewhere around 660 to 330 BCE, though the text itself reads like a copy of something even older. It's essentially a field guide for the priests of Serket, the Egyptian goddess associated with scorpions and venomous creatures, who were the ancient India produced its own dedicated snakebite manual inside the Sushruta Samhita, a foundational Sanskrit medical text. Tie off the limb, apply something to the wound, and say something over the person in case the wound alone isn't enough. Other cultures reached for tourniquets of their own, tying something tight above the bite to try to trap the venom in one place. Some tried sucking the wound, believing you could physically pull the poison back out. Almost none of it changed the outcome in any meaningful way. A person's survival mostly came down to three things nobody in the room could control: which species who had been giving pigeons small, repeated doses of rattlesnake venom to build up their resistance. Comet tried something similar. He injected small amounts of cobra venom into horses, over and over, in doses too small to kill them. The horses' immune systems responded by producing antibodies against the venom. Comet then took blood from those horses, isolated the antibody-rich serum, and by 1895 had something that could be injected into a bitten human to neutralize the venom already spreading through their body. It worked. That same year, a horse-derived anti-cobra serum was used to successfully treat a human snakebite, for the first time in recorded history. Today, if a snake bites you, in most parts of the world you have a real chance because somebody, generations ago, was purifying an antibody drawn from a horse or a sheep that had been exposed to that exact venom on purpose.